Alright, in this bonus video for chapter 4, we're going to be proving the triangle angle sum theorem. And remember, what that theorem states is that a triangle, no matter how we draw it, all of the angles inside of it will always add up to 180 degrees. So, here we are given triangle ABC, and we want to prove that angle A plus angle 2 plus angle C equals 180. And as you can notice there, looking at that triangle, angle A, angle 2, and angle C are all the interior angles of that triangle. So, just keep in mind, this is a longer proof, this is why it's a bonus. We're going to start with our given, we're just given that this is a triangle. And we're going to start by saying that if we draw some line PR through point B, we can ensure that it's parallel to AC, and that's due to the parallel postulate. And we talked about that a couple sections ago. That mainly means that if we have any line and some point outside of the line, there's one line that I can draw that would be parallel to it. So I have line AC, I'm drawing PR, I know that those are parallel lines. Next, I'm going to look at this and say that angle PBC and angle 3 are supplementary. And if I kind of highlight those angles, I can see that they form a straight line. So my reasoning there is that linear pairs are supplementary. Remember, a linear pair are two angles that make a straight line. And we know that supplementary angles add up to 180 degrees. So from here I can say that the measure of angle PBC and the measure of angle 3 add up to 180. Why? That's the definition of supplementary angles. Now I'm going to also look at this and focus on angle PBC, and I see that that's made up of angle 1 plus angle 2 put together. And that's why the angle addition postulate. Now, I can look at this and say that angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Now, you can kind of go two routes here and look at that and also say that they're linear pairs. Although, using the two lines from before, I have that statement here saying that the measure of angle PBC plus the measure of angle 3 equals 180 degrees. In that next line, I set the measure of PBC equal to angle 1 plus angle 2. So, by substitution, I could make my statement for line 6. Moving on to line 7, working with those parallel lines, I could say that angle 1 is congruent to angle A, and angle 3 is congruent to angle C, because these are alternate interior angles. So, because of that, I could say that the measure of angle 1 is equal to the measure of angle A, and the measure of angle 3 is equal to the measure of angle C, because congruent angles we can assume have equal measure. Finally, I can see in my very last line in this proof and prove that the measure of angle A plus the measure of angle 2 plus the measure of angle C equals 180 degrees. Because, again, looking at that line statement in line 6, I can replace the measure of angle 1 with the measure of angle A by substitution, and I can do the same for the measure of angle 3 and the measure of angle C. And finally, I'm done.